Numerical integration. Yeah. So why we need numerical integration? So here integral 0 to 6 3x square into dx. So if you integrate, what do you get? Here 3 into, if you integrate, what do you get? X cube divided by 3 into, what is the limit? It is 0 to 6. 3 will get cancelled. You get x cube in limit is 0 to 6. So 6 cube minus 0 cube. So we will get 216. You can find out the solution. But here integration of 0 to 1 only. So I will take, so 1 by x into dx. So here you can't integrate this one here in direct method. So here, and can you integrate this one? Integral 0 to 1 e to the power of minus x square into dx. Here this one also you can't integrate here. Now here integral I will take it is 2 to 8. Integral here 2 to 8 dx divided by log x base 10 into dx. So here also you can't find out the here you can't find out the solution. So for this type of problems you can use the numerical methods or numerical integration. Numerical integration, here you can find out for integral 0 to pi by 2 root sin x divided by root sin x plus root cos x. You can find out answer for this one, but it is very difficult to find out the answer. But so that time you can use the numerical integration. And here you can find out the solution for here 4 to 5.2 into log x base e into dx. You can find out the answer for this one also, but direct integration, but now you will get lengthy method. So you can use the numerical integration to find out the solution in easy way. So here sometimes you'll get 10 solution, but very difficult in direct method. So that time you can use numerical integration. And here for this type of problems you can't find out the solution. So that time also you can use numerical integration. So you'll get an solution for this type of problems. But you'll not get exact answer. You'll get only approximate solution. You'll get approximate solution. Now this is the process of obtaining approximately the value of a definite integral. So integral a to b y into dx, or you can write integral a to b y can be written as f of x into dx when the values of y are given at some points equally distributed over the closed interval a comma b. So here numerical integration Only for definite integral you can find out the solution. You not get for improper integrals. So remember that one. Only for definite integral. Now here. So I'll take next here. General. The general quadrature formula. The general quadrature formula. See, so here I'll consider let I equals integral a to b y into dx, and I will take this here limit. So let us divide a closed interval a comma b into n equal parts. N equals parts are width equal or equidistant. So that is h equals b minus a divided by n. You have to find out the h value, so that time you have to use b minus a divided by number of equal parts, that one n. So you will get an h value. Now here, so I'll consider a equals x naught. A equals x naught, comma x1 equals x naught plus h, comma x2 equals x naught plus 2h you will get, and x3 equals x naught plus 3h. You have to remember this one. So if you continue like that, so what do you get? Xn equals x naught plus n into h. So I called this one as b. So that is interval start from a, and here b is ending here, this one. That means whatever the given interval they given, so you'll get an n equal parts, n equidistant. Here n equal parts with equal, width is equal, so that means equidistant. So it start from a. So if you end with x3 only, means you will get an b here. That means suppose if you have 1 comma 2, so a start from 1 and b ends with 2 only. You will not get 3. So remember. So next here, be the points of division. So here, let the corresponding values of y equals f of x be here occurred as y naught equals f of x naught, y1 equals f of x1, y2 equals f of x2. In previous numerical in numerical methods we define like this only, so same as it is here also we are defining. So what do you get? Yn equals f of xn. So let us approximate y equals f of x by, for convenience I am taking Newton's forward only. Newton forward interpolation polynomial, which which satisfies y suffix k equals f of x suffix k, where k equals 0, 1, 2, 3 up to en. So therefore what happened here, let I equals, I will take integral a to b y into dx. So here I take and write I equals integral a to b y into dx. I taken here, so I am considering that one. Now here I will applying forward here Newton's forward interpolation formula. So what happened here, I equals, what is a, I taken a equals x naught, and what is b here, b is equal to x naught plus n into h. So y can be written as, here y I will take, y is equal to f of x, right? Y equals f of x equals, I am taking Newton forward interpolation formula, so I am taking here. So what do you get, y naught plus r into delta y naught plus r into r minus 1 divided by 2 factorial into delta square y naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube y naught plus so on plus r into r minus 1 so on r minus n plus 1 divided by n factorial into delta to the power of n y naught into dx where what is r here, r equals x minus x naught divided by h, right? So if you substitute r is equal to x minus x naught divided by h, then limit also changes. So what happened here, if you put x is equal to x naught, if you put x is equal to x naught, what happened r here, so x naught minus x naught divided by h, so you will get 0. Now if you put x is equal to x naught plus n into h, x naught plus n into h, so what happened here, r value, r equals what do you get here, x naught plus n into h, here I am substituting here minus x naught divided by h, these two will get cancelled, so n into h divided by h you will get, so h will get cancelled, so you will get n. So r lies here, what do you get, therefore r varies from 0 to n, r varies from 0 to n. Also what you get, dr by dx equals 1 over h you will get, that means dx is equal to h into dr. Now we have I equals integral, what do you get here, lies between, r lies between 0 to n, r lies between 0 to n, so y naught plus r into delta y naught plus r square minus r into delta square y naught plus so on into what you get, h into dr. So what do you get here now, here dx can be written as h into dr, I am substituting here. So after, if you integrate here, what do you get, with respect to r you have to integrate, so r into what do you get, limit is you'll get, now 1 is there, if you integrate, what you get, r you'll get, what is the limit? Limit is 0 to n, so I'm substituting here into y naught plus r square divided by, here r square divided by 2 into, what is limit? It is 0 to n, and here into, what you get, delta y naught is constant, I'm writing here, and here what you get, r cube divided by 3 minus r square divided by 2 into what is the limit? It is 0 to n into delta square y naught plus so on here plus so on. So h is there, so I'll take h is here common. Okay, so what do you get? h into n into y naught plus n square divided by 2 into delta y naught plus, if you apply here, what do you get? N cube divided by 3 minus n square divided by 2. If you apply upper limit and lower limit, you will get this one into, what do you get, delta square y naught, I'm sorry I forgot n here, 2 factorial divided by 2 factorial plus so on. So this is your this is called general quadrature formula. General quadrature formula. Now here, if you varies n, you will get different types of formulae. So let's check out that one. Now here, trapezoidal rule. First one, trapezoidal rule. So here, this is not important, okay? From using this one, you'll generating the formulas, so that formulas is very important, remember that one. So first one, here if you put n equals 1, you'll get an trapezoidal rule. No proof for these things, so only I will write the formulas. So if you put n equals 1 for this one, so you'll get y naught plus delta y naught and delta square y naught. Next you'll get delta cube y naught. So here y naught can be written as same as it is. So delta y naught can be written as, what do you get, y1 minus y naught. Here to substitute that one. So delta square y naught means, what do you get here, delta square y naught equals, can be written as delta y1 minus delta y naught. So delta y1 means, what do you get, y2 minus y1 minus of, what do you get, delta y naught means y1 minus y naught. So what do you get, y2 minus 2 times of y1 plus y naught. So if you substitute all those things for delta cube y naught also, you will get some expansion for like this only. So if you simplify, you will get trapezoidal rule as, I'll define I equals x naught to x naught plus n into h. This is A and this is B here, remember B. So what do you get, y into dx equals h by 2 times of y naught plus, what do you get, yn plus 2 times of y1 plus y2 plus y3 plus so on plus y suffix n minus 1. Y suffix n minus 1. If you put n equals 1. Now if you put n equals 2, you will get the rule Simpson's 1/3 rule. Simpson's one-third rule, or you can write this one as Simpson's one-third rule. So if you put n equals 2, you will get here for this quadrature formula, so you will get the Simpson's one-third rule. So what I get here, I equals here a equals x naught and b equals what I get, x naught plus n into h, y into dx equals, you will get h by 3 into y naught plus yn plus 4 times of y1 plus y3 plus so on plus yn minus 1 plus 2 times of y2 plus y4 plus so on plus yn minus 2. So what you get here, 2, 4, 6, 8 all are comes here. Here you will get y1, y3, y5 only odd, 1, 3, 5, 7, 9, 11 like that. So next one here, Simpson's 3/8 rule. Simpson's 3/8 rule. Now you can write this one as in words also, Simpson's 3/8 rule. So when you get Simpson's 3/8 means if you put n equals 3, means n is multiples of 3 here, you will get in Simpson's 3/8 rule. N must be multiples of 2, you will get Simpson's one-third rule. So remember that one. So what you get here, I equals integral a to means x naught to x naught plus n into h y into dx equals here 3h by 8 into what you get, y naught plus yn plus 3 times of y1 plus y2 plus y4 plus so on here y suffix n minus 1 plus 2 times of y3 plus y6 plus so on plus yn minus 3. Here this should be n multiples of 3, 3, 6, 9, 12, 15 like that you will get here. Here without these numbers you will get here. So that means 1, 2 without 3 is multiples of 3, 2, 4, 5, 7 and 10, 11 like that. So this is your Simpson's 3/8 rule. Now fourth one, Weddell's rule. So n must be a multiples of 6. Sorry, before going that Weddell's, I want to take another one. So that is Boole's rule. N is a multiples of 4. That means if you put n equals 4, you will get an Boole's rule. So you will get I equals integral a equals x naught to b equals here x naught plus n into h, x naught plus n into h, y into dx equals, we will get 2h by 45 into here we will get an 7 times of y0 plus 32 times of y1 plus 12 times of y2 plus 32 times of y3 plus 14 times of y4 plus 32 times of y4 plus so on. So here Wedel, fifth one, Wedel's rule. So for n equals 6, not for n equals 5. It is Wedel's rule for n equals 5. So what happened? I equals, here you will get 3h by 10 into summation I equals 0 to n k times of y suffix I, where k equals 151,615, comma 251,615,2, so on. I will tell you how you get this one. So what I get, I equals integral x naught to x naught plus 6 into what do you get here, n into h in y into dx equals, here 3h by 10 into, here you will get y0 plus 5 times of y1 plus, here what you get, y2 plus 6 times of y3 plus 7 y 1 times of y4 plus 5 times of y5 plus, here what do you get, this becomes 2. So 2 times of y6 plus 5 times of, what do you get, 5 times of y7 plus 1 times of y8 plus so on. So here if you go for, if you put n equals 6, what do you get, here 1 times of y0, 5 times of y1, and here 1 times of y2, 6 times of y3, and here 1 times of this, sorry, this is 1 time only, 1 times of y4 plus 5 times of y5 and 2 times of y6. If they asked n equals 6, then what happened, this becomes 1, 2 becomes 1. Remember that one, if you ask n equals 6. So and here no need to write this one. If you asked n equals 6, you will get up to y6 here to write. So 2 becomes 1 because here also coefficient is 1, so last end with also 1 only. Remember that one. So now here you don't have formula for n equals 5. Remember the ones, they still studying on n equals 5. Maybe they find out or may not be. So still it was searching for n equals 5 formula. Now so look at here, take a note. So to apply trapezoidal rule, n must be a multiple of, what do you have, 1 here. So n must be a multiples of 1. 1 1s are 1, 1 2s are 2, 1 3s are 3, like that. So n must be a multiples of 1. And here to apply Simpson's one third rule, n must be a multiple of 2. N must be a multiple of 2 means 2, 4, 6, 8, 10, 12 like that. So multiples of 2. And here the one to apply Simpson's 3/8 rule, n must be a multiple of 3. Multiples of 3, what do you get? 3, 6, 9, 12, 15, 18 and 21 like that. N must be multiples of 3. And here to apply Poole's rule, n must be a multiple of 4. N must be a multiples of 4. That means 4, 8, 12, 16, 20, 24, 28, 32 like that. So to apply Wedel's rule, n must be a multiples of 6 means here 6, 12, 18, 24, 30, 36 like that. So n must be a multiples of 6.